So the final video on momentum for now is conservation of momentum. So a study of momentum can describe the motion of interacting bodies mathematically. And the two common interactions that we look at are explosions and collisions. So explosions can be thought of as a single object separating into two or more fragments, which makes sense. So it could be anything, like if you're holding something and you throw something away, then that can be considered an explosion. A collision, on the other hand, are when two bodies collide with each other, and what can then happen, whether they stick together or separate. Okay, so the important thing to remember is that if we have a closed system, there's no change in the total momentum of the system. So we've got the law of conservation of momentum, and in a closed system, let's write this down, in a closed system, change in momentum, so delta P equals 0. So what we can say is that P initial equals P final. So this bit here is just really important. You'll be using this a lot. So if we look at our first example, we've got a boy on roller skates is travelling along at 8 meters per second. So this is our initial velocity. He has a mass of 60 kilograms, so our mass, and is carrying a school bag of mass. Actually, I'll rub that up because I didn't read the rest of the question. Mass 10 kilograms, so we've got two masses there. He throws the bag directly forward at 20 meters per second relative to the ground. Calculate the boy's speed after the explosion. So let's list our things that we know. So we know that these two things are together. So you've got the boy and his school bag. So it's the boy plus bag system. That's one thing. It's like one block. And then afterwards, you've got the boy plus the bag. You've got two things. So let's call M1 the boy's mass, which is 60 kilograms. M2 can be the bag, which is 10 kilograms. U of both things, because they're together, initial velocity, is 8 meters per second. Now, V1. We've called M1 the boy, so we need to be consistent. So V1 is going to be the boy's velocity, which we don't know. We want to work that out. And V2 is when he throws the bag directly forwards, so that's 20 meters per second. So it's just really important to be consistent. We've got like item number 1 here and item number 2 over there. So we know that Pi equals Pf. Now initially the momentum, remember that momentum is mass times velocity. Now initially the boy and the bag are one thing, so it's going to be M1 plus M2 times the initial velocity u, okay? So that's the initial momentum. Now for the final momentum, we have two different bodies, so we're going to have two momentums. We're going to have M1 V1, which is the boy, plus, because it's a closed system, M2 V2. So this is the boy. So I'll just write that down. This is boy, and this is bag. Okay? So now we can start to put in our values. So we've got 60 plus 10 times 8 equals the boy's mass is 60. We don't know his velocity, that's what we want to work out. We know that bag's mass is 10. And we know that he's throwing the bag forwards at 20 meters per second. Which is pretty fast, actually. But he must have been moving, he's moving 8 meters per second, so that's alright. So now when you do this, you get 560 equals 60 v1 plus 200. So when you rearrange, you're going to take 200 from both sides, so you're going to get 360 equals 60v. So therefore v1 is going to equal 360 over 60, which is 6 meters per second. You can do that in your head because these zeros cancel out and 36 divided by 6 is 6. So, we now know what the boy's speed or velocity was after the explosion. Now, I did say speed, so you could just answer 6 meters per second, but we haven't had a change in sign, so therefore it must be going forwards, and he must be going forwards in the same direction he threw the bag, and in the same direction that he was originally travelling. So there's been no change. Okay. Next question. We're going to look at collisions. So there's two types of collisions. There's rebound collisions, where objects bounce off each other. So thinking maybe billiard balls, if you play pool, then the things bounce off each other. Or there are coupled collisions, where objects remain locked together. And you see that quite a lot, either like a bullet into a target, or sometimes in car accidents, the cars, or particularly if it's a truck and a car, they often get stuck together. And whether it's a rebound or if it's coupled actually changes the way that we do these questions. So, if you've got a rebound, then the momentum equation that you're going to use is just like the previous one. Well, it's kind of similar. You're going to have, you've got two things originally, so this is our initial velocity. So we have two objects, and you can have as many objects as you want. You could have 10 objects all colliding, that's fine. So you'd have m1 u1 plus m2 u2 if you had more, plus m3 u3, so on and so on. And then they rebound, so nothing sticks together. So you're just going to have the same thing on the other side, but with the final velocity. So m1 v1 plus m2 v2, and you could keep going for as many objects as you had. You're not creating any objects, so they're just bouncing off each other. That's not an explosion. So we've started with the same, start and finish with the same number of objects. So our example here is that a car with a mass of 2 kilograms travelling at 6 meters per second collides with another mass of 0.4 kilograms travelling in the same direction at 2 meters per second. So here we can automatically start to say that this is our object 1, and then the other one over here is number 2. Bounces off. The 2 kilogram cart travels at 3 meters per second in the same direction. So here we're starting to talk about our final velocity. This is our initial velocity up there. Calculate the velocity of the 0.4 kilogram cart after the collision. Okay, so if you want to know what this actually looks like, you've got 2 kilogram cart, imagine these have wheels, and it's travelling at 6 meters per second. And you've got the other one, which is 0.4 kilograms, and it's going the same direction at 2 meters per second. That's before. And then afterwards, you've got this one, our 2 kilogram one, going at 3 meters per second, and the other one, our 0.4 kilogram one, is moving at a speed we don't know, so I'll call that one B2. Okay, so we can just go ahead and plug our numbers, our values, into the equation up the top, this one here. So m1 u1, so m1 is going to be 2, u1 is 6, plus m2, 0.4, times u2, which is 2, equals 2 times 3, so that's our v1, our final velocity of the first object, plus 0.4 times v2. So then you can go through and work all of that out and rearrange, so you're going to end up with 12 plus 0.8, and then we can subtract the 2 times 3 from the other side, minus 6, and we're going to have to divide all of that by 0.4 in order to get v2 by itself. So I've just gone through and I've rearranged that. I've done a couple of steps in one step, so feel free to write out every step. That is completely fine, and just keep practicing rearranging equations. It's absolutely vital for physics. And you're going to get an answer when you put that in a calculator of positive 17 meters per second, which means that it's going in the same direction. Okay, so that's that question. We've solved that one. Now, coupled collision, so when they stick together. Here, this is like the previous example that we did on the previous slide. So they stick together, so one side is going to come, I'll just write the equation down here. So if they're going separately, you're going to get the same thing as before, m1 u1 plus m2 u2, and then they're going to stick together, so you'll get m1 plus m2 v. So it's just like the one with the school bag, except just on the opposite side. So the final, they're stuck together, whereas in the school bag and the boy on the roller skates example, they were together and then separated. So let's have a look at our example. We've got supermarket trolley loaded with shopping, has a mass of 60 kilograms. It rolls away at 4 meters per second, hopefully not in a car park, and collides with an empty trolley of mass 25 kilograms, which was stationary. They become stuck together and roll on as one, hopefully not into someone's car. Calculate, I can't spell, that's meant to say calculate, the velocity of the two trolleys when locked together. So I want you to have a go at this one by yourself and then come back. Okay, so mass 1, let's make that the loaded trolley, so that'll be 60 kilograms. Its velocity, its initial velocity, u1 is 4 meters per second. It collides with an empty trolley, so mass 2 is going to be 25 kilograms. And it was stationary, so u2 is 0. They come stuck together, so m1 plus m2 is going to equal 60 plus 25. And we don't know what v is. So let's plug that into our formula. I'll just rewrite it. So I've got m1 u1 plus m2 u2 equals m1 plus m2 v, so bracket. And so we're going to go 60 times 4, which is our mass 1, the loaded trolley, and then 25 times 0, which equals 60 plus 25 v. Now you'll notice this one that has an initial velocity of 0, that's just going to totally disappear out of our thing because it's got no momentum at the beginning. So before it's a stationary, it has no momentum. It's not moving. So you can only have momentum if the objects are moving, because the formula is mass times velocity. Okay, So then you will get 6 fours are 24, so 240 equals 85v. So if you rearrange that, you get v equals 240 over 85, which is 2.8 meters per second. So these are the kind of problems you're going to have when you're doing momentum and collisions. So the steps are that you've got to identify what's actually happening. Do you have an explosion or a collision? So I'll just write this down for you actually. So we've got step 1 is it an explosion or a collision? I can't spell tonight. You know what I mean. Is it a collision? Drawing a diagram can help. So even if it doesn't say draw a diagram, if it helps you work out what's going on, drawing a diagram can really, really help. And then you can work out which one's M1, U1, and then M2, U2. So make sure you work out the M1s and the U1s, and the M2s and U2s. And then after that, it's just a case of choosing the appropriate formula and making sure you understand what's going on with the formula. Like that this one clearly says that beforehand they're separate. Up here they're separate and then they're joined. So that means that they're joined. So you've really got to understand how those formulas work. And then you just go through and do parameters, formula, sums to calculating. Thank you.